Alright, this video is for the Language of Algebra worksheet 4-3, and in this one we're solving unknown equations. We're doing equations that have fractions that you have to resolve first. We're doing inconsistent, inconsistent, and all real number equations as well. Alright, so go ahead and pause and check yourself. You'll notice on the really hard ones, which are 7 through 12, I have put kind of like the steps so that you can check your steps and whatnot as you go along. All right, so go ahead and pause and figure it out. I'm going to go ahead and start getting ready, so make sure you're paused. All right, this first one's not too bad. I got to get my p's to the same side. So this one's negative. In order to move it to the other side, I got to make it positive. So I'm going to have p plus 2p on one side. If I move this 12, this negative 12 to the other side, it's going to become positive because I'm following order of operation. If it's negative, it will be positive. If it's multiplying, it will be divided. So let's clean this up. This has an understood 1, so that's 3p. And over here, 12 minus the 5 will give me a positive 7. Divide both sides by 3. And p equals 7/3. All right. In this one, to be able to flip-flop the sides, I'm going to keep the w over here. The 3 over here is positive, so when it comes to the other side, it's going to be negative. And when this negative 9 goes to the other side, it's going to become positive. So now I've gotten everything over to the side it needs to be on. All right, this has an understood 1, which gives me a negative w. So these answers, All right, 14 plus 9 is 23. Divide both sides by the negative 2. W equals, well, it's going to be negative. So I know I think I dropped my negative sign here. 2 goes into that 11 and 1/2. Or you could use 0.5, but I did forget my negative. All right, so to bring this t to the other side with the other t, it's negative here. It's going to become positive when it goes to the other side. And this 14 is negative, and it's going to become positive when it joins the 8 because it has to follow that opposite operation. And I can subtract 14 or add 14 to both sides. I can do all of that. I'm kind of skipping that because I'm guessing by this time we're really good with our equation solving, and I am lack of room on here. All right, so t plus 1t plus 7t is 8t. 8 plus 14 is going to be 22. Divide both sides by the 8. 8 can go into 22. Let's see. 2 times was 6 left over. So 6 over 8, which I can reduce down to 2 goes into 6 3 times and into 4 and into 8 4 times. All right. So the k is going to stay on this side. I'm going to bring this 10k to that side. It's positive here, so it's going to be negative. Bring the 23 to the other side, which is going to make it a negative 23 minus 5. And if you do the railroad method, this is the way it will work out too. It's going to give me a negative 9k on this side and a negative 28 on this side. Well, I'm going to divide both sides by that negative. 2 negatives is going to give me a positive for my answer. 9 goes into 28 3 times with 1 left over because it's 27. So 3 1/9. All right, so 3x, bring this over to the other side, making it a negative 6x equals 21. This is going to give me a negative 3x equals 21. Divide both sides by that negative 3, and we're going to get x equals a negative 7. All right, let me bring that 3y to the other side, making it a positive. And that's going to give me 17y equals negative 84. Divide both sides by 17. All right, and 17 can go into 84. I believe it's 4 times. Let me look real quick. It is 4 times. Okay, so that is going to be 16 left over. So 16 over 17. All right, the next ones are all showing different rules. Okay, so the first rule of math is that I can get rid of that 4 first. Okay, but that to get rid of the 4 first, I have to, because that's division. Division does not have to have like terms. So to get rid of that 4 first, I have to do it by everything, which is okay. I can solve it that way. And actually in this situation, it is the easiest thing to do. All right, so the 4 is dividing k. So to get rid of it, I'm going to multiply it by everything. Remember, multiplication and division doesn't need to be like. We don't have to have like terms. So I can do it to everything, whereas adding, subtracting, I only would be able to do that to the other k terms. All right, so this is going to get rid of this. This is going to cross out that. It's the opposite operation. I'm going to have 24 plus k equals 1656 minus 8k. Now I can get my like ones together. So k, bring this 8k to the other side, makes it addition. Bring the 24 to the other side, makes it subtraction. This is going to be 9k. And that is going to be 232. Divide both sides by 9. Okay. And I'm pretty sure that cannot go into that. Yeah. So it's going to be yeah, this is wrong. Where did I make my mistake? Oh, I didn't make that. Okay. All right, so I forgot to multiply that second k, but that's okay. The answer is actually 3 5/9. Okay, 3 5/9. All right, now 8 is explaining the same rule that we learned in class, and that is that I can multiply first. That 9, because to get rid of that 9, we have to multiply, right? Because it's dividing the y. The thing is that if I multiply by 9 first, I have to do that to everything. So 13 times 9 is going to be 117. That's a negative 117. These are going to cancel, just leaving me with y. 24 times 9 is going to give me 216. It's going to be a negative 216. And the last one is 9 times 9 is 81. It's going to be a negative. So that is my answer. All right, let's get our like terms on the right sides now. When I bring this over, it becomes positive. When I bring this over, it's going to become positive. All right, this is going to be 82y over here. 216 minus the 117, because we have to do that because of our signs. It's going to give me a 99. All right, so 99. So now we're going to divide both sides by that 82, right? Oh, this should be negative. I'm sorry. This is the bigger number. All right, so a negative 99 divided by the 82 is going to give me, I'm running out of room on these. 1 and 17 over 82, and it's going to be negative because the 99 is negative. Let me write out this step. I have a little bit of room. Okay, so we learned in class that if the same thing with the same sign is on both sides, it's going to cancel out and be inconsistent. If our x's cancel out, it's inconsistent. Let's see why. All right, so I'm going to do this one slower than I've been doing them. If I want to move this to this side, I got to subtract it, right? So subtract 5x from both sides. Okay, so negative 5x and 5x is 0. 5x minus 5x is 0. I'm left with negative 27 and 2 on the other side. Negative 27 in no universe equals 2. This is a not true statement, which means it's an inconsistent equation. It makes no rational sense. All right? So the trick is that when I see this on either side, when I turn this into subtraction to move it over, okay, it's going to cancel out. All right, so this next one again this one's just fairly simple, thrown in there after some of these hard ones. So I'm going to do it over here. Negative 41n equals negative 2 minus 13n. Bring this to the other side, making it positive. Plus 13n equals negative 2. So 41 plus that, the negative 41 plus that 13 is going to be a negative 28n over negative 2. We have to divide both sides. Don't fall into the trap of dividing by 2, because your eyes want to make it right, and that doesn't look right. So it makes sense that that would be the mistake you make, and make the answer positive 14. It is going to be positive because of a negative and a negative, but I'm actually dividing by the 28. So that means that the 14 is going to be on the bottom. It's going to be 1/14 because dividing is just fractions. And if I reduce this, this is the bigger numbers on the bottom, so it has to remain the bigger number on the bottom, right? All right. So in this one, we have another thing that is the same on both sides, and it's this 3, and it's the same idea as this 5x. They're going to cancel out. And as you see, I put some of the math here because this one's a little bit harder to see. All right, so first thing is I went and I multiplied everything by 7, and you should get 21 plus 7 equals 21 plus 98x. Now, if I decide to get my x's together, as I did here, and my 21s together, as I did here, you see that they subtract each other, okay? And if that happens, it becomes a 0, all right? If I combine these, I'm going to get, and I'm just going to add a little step in here that I didn't do, a negative 97x equals 0. Well, no matter what I divide by, the answer is always going to be what? It's going to be 0. All right, and I told you guys that that means the solution is all real numbers. Doesn't matter what x is, it's going to come out to 0. This equation will always, no matter what x is, come out to 0, and that's because of this line right here. No matter, I could put a 2, I could put a 3, I could evaluate for 4, and no matter what number I put in there, it's going to say equals 0, okay? And this means all real numbers can go into this, all right? This last one's just another one practicing that dividing by -6. So if you are dividing by -6, you can times by a -6. Now, I can already tell you this answer is wrong because I times by 6, not a -6. All right, this should be a negative 216. This should be a positive. All of my signs are wrong. So let me just correct these really quick, and that's the only one that's right. Okay. So this is what you should actually have, and let's work it out from here. All right, so let me get my k's together. So I have a negative 16k. If I bring this k to the other side, it becomes negative as well. If I bring this 90 to the other side, it's going to become negative. This is going to give me a negative 120. All right, and this is going to be a negative 117k. So now I have to divide both sides by that negative 217, which is going to give me a positive which can't be reduced. That's not reducible. So our answer is just 120 over 117. This was our topic of of talking about these irrational numbers that come out in our equations, okay, equations with irrational numbers, and these are going to take a while to practice. If you keep looking, you'll see that I have some in the word problems so that you can keep practicing this concept of irrational answers in equations, because it's more times than not that happens in real life more than perfect numbers. Okay, so there you go. Keep practicing until you get it, and I'll see you in class.